Hello, hello.
Yes, ma'am.
Uh, uh, like in between there was internet problem. So just I have recovered whatever we did yesterday. Yeah, I guess you have listened up to fact or no?
Yes, ma'am.
Acha. So I'll explain once more like what is directory structure is all about. So directory structure is the one which contains the information of all the files within that directory. For example, on a prompt, I have created one directory called as A. Okay, in that directory A, I have created subdirectory as B, and my file is c.txt in that B directory. So the path is like A will be my one of a directory. Within that, there will be subdirectory B, and file will lie in a subdirectory B. So in that case, what will happen? There will be the entry for directory A. I node record will be there for directory A. Inode record will be there for directory B, and inode record for directory C. Okay, oh sorry, the file name c.txt. So how the directory, like what the directory is going to store all about is that this dot is my original directory. For example, here in this case, my directory is B. Okay, then dot dot is the parent directory. Like here in this case, the directory is A, and exactly the files within the directory B. So in this case, if there are three files like foo, bar, and this one more file name is there. So these will be the three directories. Okay. So the inode number for the directory will be directory A will be 5. Sorry, directory B will be 5, directory A it will be 2, and for foo, bar, and other the third file it will be inode number will be 12, 13, 24. Okay. Next, the thing that is maintained is the length of the file name. Okay. Now length of the file name, you will observe that whatever is the length or number of characters are here, plus 1 is there. So if you remember, we have said that once you have created a file, you press the enter key after that file. So every time we need to store this enter key. So if the file size is dot, then the length will be 2 dot dot, it will be 3, so on and so forth. So you count this, it will be almost 27 plus 1, that is 28. Okay, so that is one record that is maintained in this directory structure. So file name, string length, record length, and the inode number. Okay, so it is a kind of linked list of records or more complex structure. Directory is a special type of file and has a inode and data blocks of the files. Okay. Now, free space management. Now, what is free space management? If you remember, I said that for every file there is a inode number, bitmap, super block, and the data blocks, right? So we need to do the free space management. Free space in the sense, if the new file is created, which block should be given to that new file which has been created will be done with the free space management. So how the track is kept? So we using bitmaps. Okay, bitmaps for inodes and data blocks which stores 1 bit per block. So for example, on my disk there are 1000 blocks, there will be 1000 bits which are representing one block. Okay, which indicates whether the block is free or not. Free in the sense, if it is 0, the block is free. If it is 1, that means the block is occupied. Okay, and the free list, the starting point of the free list is stored in a super block. So super block stores a pointer to the first free block, and free block will store the address of next block. So it is kind of a linked list, okay, which has the pointer and the nodes. So this is super block which will contain the address of first free block, next free block will contain address of next free block, so on and so forth. So this is how the free spaces will be identified. If the new file is created, it will refer to the first of all super block, then super block will give me the address for first free block which will be assigned to the newly created file. So that is how the free space is managed by operating system. Now coming towards the couple of system calls for the file, we know that we need to create or we need to open the file. Why to open the file? Because once I'll open the file, I will get the inode of that file, which will be readily available for further operations. Like further, after opening the file, if I want to read or write or do anything with the file or append the file, I can have this inode with me. So every file needs to open first of all, and then we can do such kind of operations. Okay, so opens the file, and this system call returns the file descriptor. Okay, I hope you remember we have studied in OOP some kind of system calls, f open, f close kind of system calls. So do you remember those system calls?
Yes, ma'am.
So it returns the file descriptor. If you remember, we have used to call that as a file pointer. So pointer is kind of a file descriptor which points to the in-memory inode. In-memory in the sense the inode which is stored into the memory. Normally inodes are stored onto the disk, and the open file system reads that inode in the memory and which points to the in-memory inode. So we have two copies of inode. One is there in the disk and one is there in the memory. Why in memory? Because communication with the memory will take lesser time for processor than communicating with the disk, because disk is IO which is slower than the memory. So we have to have in node inode in memory inode. Reads and writes can access the file data from the inode. So we know that for read or write kind of operation, we can keep track of the inode. Okay. So what happens during open system call? The path name of the file is traversed starting at the root. As I said earlier, I have a directory A, subdirectory B, and there is one file called as c.txt. So it will read the inode for A, it will read the inode for B, and it will read the inode for C. So inode of root is known. To bootstrap the traversal, we need to know the root inode. Okay, bootstrap in the sense to increase the speed. Recursively, it will fetch the inode of parent directory, read the data block, get the inode of child, fetch the inode of child, and repeat until end of the file. Until we get the inode for c.txt, the operation will repeat. Fetch the inode, read the inode, fetch the inode, read the inode, so on and so forth. If new file, new inode, and data blocks will have to be allocated using bitmap, the directory entry will be updated accordingly. Okay. New file, new inode, and the data blocks will be allocated using bitmap. So we know that, as I said earlier, if new file is created, we'll communicate with a bitmap, we'll find which block is inode block is free or something like that, and those blocks will be allocated to the newly created file. Okay. Now opening a file table. Now we have talked about opening a file. Now file table. So there are two things. One is global open file name. So one entry for every open file will be there. So whichever are if there are 10 files are opened in the system right now, there will be 10 entries we can observe. Okay, along with the sockets and pipes. Sockets and pipes are the mechanism which are handled to communicate with them within the processes. Okay, you might have learned this in your computer network, sockets and pipes. Okay, and like in OOP, I guess we have studied the pipe. Okay. So entry point to in copy of inode will be there in the file table. So file table, if for example, if this is the file table, it will return me that file descriptor is 4, which will turn will communicate with a block, and which will give me the inode value for that particular file. Second thing is that Second thing is that per process open file table. So array of files opened by the process. So for one process there will be one file table. This global file table is for all the processes whichever are open. Okay. So and in this case it is like granular, like we have kept a separate file or file table for every process. So file descriptor number will be indexed in the array. So for example, this is the file table for one process. File descriptor will point to the file table, and which in turn will give me the inode value. Okay, so every process has three files: standard in, standard out, and error. Because we all know that our printf, scanf, or a scene, see out kind of statement works with a standard input, standard output. If there are any errors, the standard error file is communicated. So every process do have these three files by default. Okay, so it open system call creates an entry in both the tables and returns the file number or file descriptor number or file pointer. For like C++, it is called as file pointers, and in assembly language it is like talked about, or it is called as file descriptor. Now reading and writing file, we have used this system calls in our operating OOP subject. Okay, so for reading and writing file access in memory inode via file descriptor. So I'll be having a file descriptor like this. For example, here. So this will be the file descriptor written by my open system call. I'll communicate with the file table and I'll get the inode for a particular file. Once that inode is available with me, and inode will be from memory. Okay, I can find the location of data block because we know that in inode the data blocks locations are stored. Okay, at a current read and write offset. So for example, you have written something 2 3 lines in a file and you want to append it. So whatever is the end of third line will be there in the will be there in the inode. Okay, fetch block from the disk and perform operation. So what will happen, once I'll get the locations, I'll communicate with the disk and I'll get those blocks into the memory for further operation. If I want to read a file, I will get the location from the inode of the data blocks. Then I'll go to the disk, I'll communicate, or the processor will communicate with the disk. It will get those data, the data from those blocks, and it will perform the operation. In case of writes we may need to allocate a new blocks from the disk using a free block. Right, exactly. I said I have written 3 lines. Now I want to write the fourth line. That means my file size is going to get increased. It is going to require a free block. So operating system will communicate with bitmap. It will find out the free blocks, and within those free blocks, I'll write my next line. Yes. So in case of write, I need to find out the free blocks. In case of read, I'll just fetch the block and I'll do the operation. For example, I am reading the from the file and want to display the data on the screen. I'll read those blocks and I'll write the statement cout and I'll display the data onto the on screen. Okay, and at the end update time of access and other metadata in the inode. Because you all know, if I close this now PowerPoint presentation, my access time will get updated. So where the update happens in inode. Because we know that in inode the file creation time, file updation time, all those times are stored. Okay, now the 5 minutes are remaining, so I'll just tell you that yesterday we had a meeting and your end sem exam will take place on 5th of May only, and your T2 exam will take place after 10th of April, sorry, 15th of April. So are you online, everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So I'll repeat, your end sem exam will happen on 5th of May. How it will happen, whether you'll like online kind of thing or something like that, that decision is still need to be taken. Your T2 exam surely will be online on a VOLP platform, and it will be there after 15th of April. Okay, and your practicals will be taken by respective faculty members online only. So you need to submit your assignments to the respective faculty for your practicals. And practical exam, we have to give a think on that, we thought on that, how the practical exam will be conducted. Is it okay? You have
Yes, ma'am.
you have any problems you want to ask me? or
Ma'am, can you repeat the practical thing because the voice is breaking?
practical will be done like taken by respective faculty members with the Zoom classroom only. They'll explain you the assignment. You need to perform the assignment and mail that assignment to the particular faculty.
Okay.
Or for a time being, ask Shardul to add me in unofficial group. I'll give you the details. Is Shardul online? Shardul?
Ma'am, I'll add.
Please add. I'll give you the details, whatever has happened in yesterday's meeting. As well, there will be the HOD meeting, HOD parent meeting will be there. You might have received the a notification about the same.
Yes, ma'am.
Uh, so I'll just
Ma'am,
give you.
ask them to put the code on the main group also so that if we've not opened mails or anything, directly we'll access from TYBcom.
Can you repeat?
मैम बस कोड मेन ग्रुप पे भी डालने बोल दो ना.
मेन ग्रुप कौन सा आपका एक ही ग्रुप है ना TYBcom.
Yeah, ma'am, the main official group.
Yes. It will be there on that group only. Your class teacher will share it on that group.
Okay, ma'am.
And if you want, like whatever yesterday we have decided, if you want to just add me in unofficial group, I'll give you the inputs and then we can like I'll quit.
Yes, ma'am. Okay.
Yeah, and we need to put all these recorded lectures on YouTube. So if you have missed, if someone has missed anything, can like look on to that particular YouTube, and URL will be provided into your VOLP. That we are like confused how to do that, but we have been asked. So let us do some study about it, and I will let you know where you can find the recorded lectures.
Yes, ma'am.
Okay. So should I stop right now? Hello. Hello.
Yes, ma'am.
I'll end the meeting. I will cover this portion tomorrow because Unit 5 is very small. You might require 2 more lectures for this.
Okay, ma'am.
Okay.